In question 1, we're asked to figure out the point of intersection between two lines. The easiest way to do this is to compare their parametric equations and solve for the parameter that makes that true. So let's take this first line and make it parametric version. So 4 plus 1s, y would be 2 plus 3s, and z would be 6 plus 11s. The same thing for that one. So x would be 5 plus 2t, y would be -1. That's kind of nice. And z would be 4 plus 9t. Now we can pick any two equations we want to and solve them simultaneously. So I would suggest, just looking at this, that the y's are going to make our life a little bit easier, because we can write down right off the bat that 2 plus 3s is -1, which means we can solve for s really quickly. S will be -1. Once we've got s, we can pick any other equation and solve for t. So let's use the x's. What do we know about the x's? We know that 4 plus 1s equals 5 plus 2t when these lines meet. We also know that s is -1. So we can put that in there and then solve for t. So we'll get 3 minus 5 is 2t, -2 is 2t, t is -1. And just to check, to make sure you're on the right track, I would do the z's being equal. So 6 plus 11s, 4 plus 9t. But we know s is -1, so this is actually 6 minus 11. And we know t is actually -1, so this is 4 minus 9. So we end up with -5 equals -5, and hey, we're on the right track. So the points that we want to find, x, y, and z, remember our objective was to pick any equation and use our parameters. So x is 4 plus s, but s is -1, so x is 3. Y, well, y is -1, right? We're told that right here no matter what. Y has to be -1. And z is 6 plus 11s. Well, that's kind of what we checked when we did this thing over here, right? This is what we're checking for z in both of them. So no matter what, z is -5, and that was our check. So there's your POI. Right? 3, -1, -5. Part B, verify the intersection point of these two lines is on a plane. Well, if we're given an equation for plane, and we're given our POI of 3, -1, -5, can't we simply substitute those in for x, y, and z? That should work. So x is 3, minus y was a minus -1, plus z, so that's 5, plus 1, it's supposed to come out to 0. That's what we're verifying. So 3 plus 1, oops, you can see I made a mistake right there, right? Because it's supposed to be a -5 for z, and I can see mine was not going to verify. So that's another way of checking your math. So -5, -5 plus 1 is 0. On the left-hand side, I get 0. The right-hand side, I get 0. That point is definitely on that plane.